Okay, next, moving forward, all right, we have talked about 420. Now we want to talk about industrial communication protocol. In industrial communication protocol, you have already learned about serial communication. This serial refers to what? UART. And in industry context, the standards is called RS-232. Right? So RS-232 is the standard for serial communication. And with serial communication, we can then talk about what Modbus is, and then eventually wrap the class with OPCUA. When we talk about industrial communication protocol, there could be two cases now, either wired, which you already have experienced just now with 420. We have copper wires connecting things together, and there are signals traveling, or in this case, electrical current flowing through it to represent the signal. In today's context, with the prevalence of wireless network, all right, many things are becoming wirelessly communicated. Just like your handphone, when you reach home, you will connect to your home Wi-Fi, and all these communication are wireless. We will be looking at wire and wireless for Modbus protocol in the lab, and this is where we talk about the use of RTU, representing wired, versus TCP, referring to the use of wireless mode of communication. And for Modbus, there are registers. Later, I will share with you what are the different registers. For Modbus registers, they are quite straightforward, right? Because there are only 4 different types, and we'll talk more in the next few slides. But let's do a quick recap, all right? What other communication protocol have you learned? And I believe for those who have joined the industry during your IA, during poly days, you probably would have experienced some others. Okay, and moving forward, before we dive into the different protocol, I think I want to bring out the concept of proprietary versus open protocol. Right? The word proprietary, some of you would have thought of the link with patents, IPs, and so on. Right? Proprietary refers to specifically owned by an entity, could be a company, could be someone, and so on. And when we refer to proprietary, means that they don't usually share openly, and often you are under their jurisdiction and control, which means they would probably hide the details of how this protocol is being developed, what are the hidden algorithm behind, and so on. Therefore, the problem with proprietary protocol is that it poses integration issue, right? The integration with other brands and integration with other protocols. And of course, proprietary means that you have to always go back to the same vendor, the company that have provided the service to you previously. And this can be a problem, right? If you are trying to look at a more competitive pricing into a solution that you would like to have in the near future, then proprietary protocol may not give you the best option. So what is that then you can do is that you might want to look at open protocol. Right? So open protocol provide better interoperability, right? This is probably another new term that some of you might not be familiar with. Interoperability refers to having equipment to be able to operate, right? Irregardless whether it's from this brand or another brand. And this is the term to provide the freedom to choose different vendors to help you solve any integration issue, and at least you know what is going on within the protocol. Why? Because open protocol are published publicly, you can get information on what it's all about. Although it is open protocol, it doesn't mean that you can always use it for free. Sometimes you do have to pay for the use of this open protocol. Probably it will not be at the end user side. If you are an equipment builder, if you are going to implement some of these protocol, you may have to go back to the organization. For example, the use of USB. If you like to tag certain sensors or gadgets that you are developing using USB, you have to register with usb.org and pay a license to make use of their protocol, right? But as end user, when we buy the USB product, we just use it as it is because all this payment has been paid for already. Okay, but coming back to open protocol, why this is good, all right? Because there are a lot of supports, right? There are corporations, groups, even professional society like the professors from the universities, IHL, even government, right? They are coming together to look into the problem. When it's open, it is more accessible to everyone, right? Be it students, researchers, And as they look into it, when they use it, when they find any problem, they can often upgrade, all right, coming out with patches and resolve any loopholes. And this is the beauty of having open protocol, to have as many people coming in to work on it to make sure that it is foolproof. And of course, if you have a very good protocol and nobody use it, then it will be a white elephant. And therefore, open protocol, I think mainly for those that are freely available, a lot of software vendors and manufacturers will use them. All right, these are not an exhaustive list of open protocol, but this particular picture shows you what are those commonly available and commonly used in the industry. For us, we will focus on Modbus. Okay, we will focus on Modbus. So what are the other protocol around? We have EtherCAT, we have HUT. HUT I've described to you earlier on. All right, we have Profibus and Profinet. Okay, if you'd like to know more about this or some of these protocol, I'll leave it to you to read up on your own. For this course, IIoT, for your main assessment, right, I will be testing Modbus and also 420, all right, part of the HUT. Okay, only these two. The rest, I will not be testing because I am not providing any reference or material to you. I think that is unfair. But of course, sharing on what Modbus is all about is to prepare you to understand how to read up on data sheet and specifications. On top of that, with our lab hands-on, it provides you to have the first-hand experience on the wiring, the communication, and so that in future, when you encounter other protocol, you will know how to get going with those. I would like to have a short break over here so that you can have some time to read up on this article, and later, after the break, we will talk about some of these or discuss on these questions. And after that, we will go back to Modbus to deep dive into what Modbus is all about. Why is it important? All right, how should we understand it? So back to this article. All right, by now, I hope that you could have read it. If not, later, all right, find some time to read up on this, because this is important. This is where we are now in today's industry context, and there are companies still using old equipment, all right? And I see that there's a question coming in from Jared, right? Is brownfield considered a legacy system? Yes, you can term that as a legacy equipment. And let's us run through together. Okay, what is OT and IT? Okay, IT, I think this part is rather straightforward. All of us would have talked about IT often, one way or another, when you go to IT help desk and so on. So IT refers to what? It refers to information technology. It focuses on facilitating data flow and data gathering, more on the networking side. But there is the other term called OT, right? What is OT? It refers to operational technology, right? Operational technology, it focuses on the manufacturing operations. And the operations includes the automated machines, your equipment, and so on, right? So these are the hardware to produce things that you would like to have in the factory, in the industry. The IT is to support the exchange of data, right? You can look at IT like the road infrastructure, where there are roads, but the roads are built there to facilitate movement of vehicles, goods, and so on. But what are those materials? When we look at OT, it could be your raw mat, it could be your trucks carrying goods, and so on. Okay, I hope these two you can see and understand the difference. Of course, in the article itself, they would have described some of this already. So what is SCADA? Right, SCADA. SCADA is a supervisory control and data acquisition, right? Supervisory control and data acquisition. We talk about data acquisition first. Data acquisition is what you have been looking into for the past 4 weeks on the use of embedded system to do some sensing. And this week lab, right, you get to see how you can acquire sensor data. So what is supervisory control? When we are in the manufacturing context, you are trying to produce some parts. That could be processes, that could be automation. And in terms of this supervisory control, it can be at very high level, looking at the factory floor as a whole, right? How would you then provide some of this control strategy? Okay, so the S and C refers to the high level control strategy on how to manage your products in terms of throughput, in terms of quality. Now, coming back to the concept of interoperability, this is where standardization is to be discussed over here. Why do we want to have standards? Because with standards, everyone know where is the benchmark, everyone know how to maintain and be at the same level. And therefore, standardization is important so that we know what is going on. I give a simple example like our tripping plug. In every household, we have a tripping plug to connect our equipment to the power source, in this case to the power grid. And that tripping plug has a specific notation. All right, you cannot anyhow interchange the wiring of the tripping plug because one of them is an earth, the other two is for your AC supply. One is being neutral, the other being the live wire. Having standards allows engineers, maintenance teams to recognize what is going on, and therefore it is very important. Similar to today's topic on field bus, when we talk about communication, we need to establish a standard so that when we communicate between equipment or devices, we know what is going on. All right. Okay, brownfield equipment, I think the question asked in the group chat, all right. Why are they still around? Because this is a time of transition. We still have old equipment around. It is too expensive to upgrade everything, and sometimes it can be costly. Therefore, in the article itself, they have described why is it a problem and so on, and is it really cheaper to replace all the equipment, or should you then integrate legacy equipment with new features, right? For example, back to the question talking about legacy system that doesn't even have a communication port, right? If there isn't a communication port, how can you then make the machine connect to the internet? And this is the part where in our class and lectorial, you will learn about how to enable some of these things which are not connected to the internet in the first place with the knowledge learned with regards to the use of Wi-Fi, the use of Modbus. Can you then help the equipment connect to the internet? Okay, so this part, I mean, this bit of whether or not to replace or to upgrade, it is really dependent on every use case. Not all cases are the same, and someone need to assess, all right, the effort required, the equipment, the hardware, and how can we go about doing it. And to the worst scenario, all right, brownfield equipment being legacy, the key personnel who left the company, if there's no proper documentation of legacy system, then there's no way for you or for anyone to really know how to interface. And the key issue here is that in order to reverse engineer and to recover all those details information, it may be too costly as compared to replacing the equipment. All right, so do be careful. And I think often, at least myself also in the same situation, when we rush, all right, when we rush for whatever that we are busy with, we just want to solve the problem, right? Without proper documentation, one fine day when you relook at the same machine that you have created a solution for, you will probably forgot, all right, what was that you have made. Right now that you have to reservice the system, it becomes very problematic. So an advice for all of you as you work on your project work, as you write your Arduino code, do make a point to write comments, right? Why are you doing this and so on, so that later on when you need to do any modification, those comments in your Arduino sketch can be helpful to ring some bell or to recollect what was that rationale behind having that few lines of codes. Okay, with regards to greenfield, all right, we are talking about coming up with new equipment, line of manufacturing, and so on, which give you the flexibility, right? And because it is something not there yet, you have the luxury to decide. Therefore, let me caution you, all right, the choice that you are making is critical because you will be stuck with the machine after it has been implemented, right? So be careful with what you ask for, especially in terms of the communication. Recall, earlier we talked about open protocol, and towards the end, I'll wrap up on the use of OPC08, which is one of the industrial norm nowadays for newer equipment. Okay, with this, I wrap up. This is more of an exercise for you to understand where we are now. And I think it's timely as many of you or all of you will be embarking on your IWSP journey soon. I am not sure what kind of equipment you will be getting. If you happen to encounter legacy or brownfield equipment that your IWSP supervisor wants you to look into, then I hope that you would quickly ask them for documentation and information first, right? If there are no information, then you have to maybe go through the hard way to recover or to test to find out what are those hidden specifications.